In this video, I'm going to talk about the definition and the generation of a sine wave, as well as the expression of AC sine wave function. AC is defined by electric current whose direction reverses periodically and is generated when there is a constant alternation of the flux. In particular, let's have a look at this physical phenomenon. Here we have a magnet and a loop. When the magnet is moving, the magnetic field will penetrate through the surface, and so the number of the field lines cutting the surface will constantly change. According to the Faraday's law, you will end up with the voltage is generated. And the generated voltage is expressed by the following formula. Vt is equal to V0 times the function of sine. Vt is the instantaneous value which the magnitude of the waveform at any instant time. To make clear, I'm going to explain each term contributing to this function. V0 is the maximum voltage or the peak value as measured from its average. So here, the inductor will cut the most amount of flux line. And what is average? Average is going to add all the value in the wave and then you divide them by the period. So when we consider one cycle, the average value of the sine will always equal to 0. The next value is V peak to peak. It is shown by the red line. It is simply the full voltage between the positive and the negative peak. The next term is the frequency. The frequency simply indicates the number of cycles it switches per second. Last but not least is the phasor. The phasor is simply a vector rotating around its origin. Importantly, the projection of a phasor on the y-axis is the instantaneous value. For example, at t equal to 0, v will be equal to 0. So the projection of the phasor on the y-axis must be equal to 0. Therefore, the vector must be lie at this position. After a quarter of the period, for example, it will rotate and reach the maximum value. So it will be equal to this point on the graph, the maximum Vmax. And after a half of the period, it will equal to 0, equal to this point on the graph. And if it continues to rotate, it will return to the initial value where it finished one cycle. So based on the formula, we can identify the value of the voltage at any specific time. Thanks for watching.